Hey there, my name is Sam Merlus, chemistry and chemical engineering double major. And first of all, I would like to tell you you're definitely one of my heroes and definitely one of my inspirations to come into Tuskegee University, apart from Dr. Floyd Smith, Booker T. Washington, and George Washington Carver.
Thank you so much.
My question is, I'm currently working on producing some polymer nanocomposite that can be used for applications that you're currently working on, such as the thermoelectric converter, but I'm working on thermoelectric generators. So I don't know, I want to know briefly what's the difference and how do they compare, or are they similar?
Okay.
In addition to that, I would like to know what book would you recommend an aspiring chemical engineering or any student at Tuskegee or any school student anywhere to read to enable them to be a more applicable person in society?
Interesting. Okay. Let's see. Let me try to answer your first question first, which is a little bit easier. Thermoelectric converters, solid-state devices, usually semiconductors that convert heat to electricity. Seebeck effect, Peltier, cooler, right? I assume that that's what you're talking about. That's a solid-state device that is a semiconductor-based technology. This is a thermodynamic technology that I'm developing, meaning that we're using a gas as a working fluid. I'm using electrochemistry to compress the gas. I use what's called membrane electrode assemblies to pump hydrogen from low pressure to high pressure and do that at low temperature, and then send it over to a high temperature stack and expand from high pressure back to low pressure at a high temperature. I get a much higher voltage out to do that at high temperature, and then it takes to compress it. So I ended up with a net energy output from the device. So it's a different technology in that sense. I thought at one point you were going to ask about electriques, which is a mechanical device, or even piezoelectrics, which are materials that you can flex that will generate voltages. That's a whole. I'm sorry?
I said I'm also working on that as well, but that's further research at Caltech.
Okay. There are a number of advances in that technology. In fact, for the electriques, I have some ideas and things that I'm working on as well. In terms of what to read or sources of inspiration, I was just thinking the other night, in fact, back when I was working on spacecraft and doing all these things on my day job, and I'd go home tired and stuff, and sometimes I wouldn't feel like doing anything. And I think to myself, I'm okay, I've got income, I have pretty comfortable life here, I'm doing some meaningful work. And it wasn't enough to motivate me. But then I started thinking about coming up with ideas that would have impacts on other people, on their lives, doing things that make people's lives better. And then all of a sudden, and then the whole idea of controlling where the benefits go. If you can create technology, there are some ills in the world. If I could get resources, income, money from that technology to have some impacts on some things that were important to me. So all of a sudden, the motivation was there. It's not so much benefiting me, but the motivation, a desire to have an impact in a positive way. The other part was that, recognizing at some point that I'm doing things that a lot of people, and solving problems that a lot of people were saying were not solvable. The engine, for example, we went and presented that to the Navy at one point, and they literally kicked us out. The guy stood up in the room and said, "How dare you come in here claiming you can do something? This will never work." Well, that was before Popular Mechanics awarded it as its number one, or top 10, one of the top 10 world-changing inventions. So people, tell you can't do stuff. After a while, you start realizing, well, maybe I have a gift. Maybe and what comes with that is a responsibility to use it in a meaningful way and not to squander or waste it. So motivation comes from a lot of different things.
Thank you.
Thank you.
If you could all give Mr. Johnson a round of applause. Thank you. And on behalf of Tuskegee University, the Office of the President, the Office of the Provost, the Lyceum Coordinating Committee, we would like to extend a great thank you for sharing with us what motivates you to test the boundaries and set goals that defy conventional understanding. Your presentation today helped to further influence our students, faculty, staff, and guests to use technology and to rethink and improve the very things around us, ultimately challenging us to switch on our brains. You have given our students an example of the success that true hard work and dedication can lead to. Thank you for returning to Mother Tuskegee.